final exam review packet. This is page 2. We're now moving into graphing. Now that we have a solution, what does that look like on a graph? First one up is just simply completing the chart and graphing it. So what do? We substitute that -1 into this equation, which happens to be an equation of a line. So this goes into there, and we get our y value. So this is -1. This equals y equals -3 minus 4, y equals -7, and that's what we put there. It's as simple as that. We do the same thing with 0. Y equals 3 times 0 minus 4. That's y equals -4, because that 0 times 3 is 0. And that becomes what we put there. And then our third point is y equals 3x minus 4, and we are going to substitute for x a 1, and that means y equals 3 minus 4, y equals -1. There it is. Those are the 3 points, and that's all we actually need to graph this. All right, create a graph. This is our y-axis, this is our x-axis. We want to make sure we make it a complete graph. We show the origin is 0, 0. And we are going to graph -1, -7. So I'm going to go -1, 2, 3, 4, 5, 6. +1, 2, 3, 4, 5, 6. +1, 2, 3, 4, 5. And -1, 2, 3, 4, 5. At least that gets our grid going. We know then that the units are 1 each. So we can label those. That's 5, that's -5, that's 5, and that's -5. Very important that you show on a complete graph, which is really what 8 and 9, question number 8 and 9 is all about. You have to show these elements and what is the scale, what are the units, that kind of thing. Where is the origin, where are the axes? So from here, we go plot those points. -1, down 7. So 1, 2, 3, 4, 5, 6, 7. So we're right here. That's our first point. -1, -7. I'm going to label it. It won't be perfectly accurate, but we'll do the best we can. 0 and -4 is a very special number. 0 for x means we don't go right or left, we go down 4. And that is our y-intercept, because that's where the line's going to cross the y-axis. 1, -1 is here. I'm not going to label it because we're running into getting messy. We don't actually even need that point, but to draw a line, we actually only need 2 points, actually, because that's all you need to orient the whole thing. And here we go. That's the line. Now, to make it a complete graph, we want to actually put y equals 3x minus 4, okay, on there, and that makes it a complete graph. It shows, a lot of people forget to put the equation on. It's very important to put the equation to label the graph. And this is a positively sloping line, and that's reflected in the fact that this is a 3. In other words, that is m, so that's our slope. M equals 3. You wouldn't have to put that on the graph, but I'm just showing for interest. And our b, our y-intercept, is -4. That's the all-important y equals mx plus b in action as a positively sloped line with slope 3. Y-intercept -4. Very interesting to note. Always, 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 wherever the line crosses the y-axis, it's when x equals 0, okay? X equals 0. All right, so let's do the next question. This one is related to graphing. It's about Dominic's baseball data. And yes, it's NBA time for those of you who like NBA. It's playoffs. And let's say we got a guy named Dominic, and he is playing a bunch of games this year. Game number 1, 2, 3, 4, 5. It shows the total number of baskets that he scores in those games. And we look for a pattern. And right now we look at this, and there's a difference of 2. Everyone, obviously this goes up 1 by 1, but these ones vary a little bit. This here varies, that goes up by 2. This is by 7, by 7, by 7. Aha, we realize that, oh, the pattern is that it goes +7, all right? Every time. We're not going to worry about the fact that this was only +2, because that was like what's called an anomaly. It's not actually sort of the regular pattern. And from there we can do what's called, we can extrapolate, which means predict what will happen at game 20. But the first question they ask you is plot a graph with these data points. So let's just do that. Make a graph okay? And again, for complete graphs, we want to make sure we put the y-axis, the x-axis, the origin is there, 1, 6. So looks like, again, we're going to be looking at a scale unit factor of 1. So 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. Very important to know that these are the game number, but I am going to, of course, need to put the total number of baskets here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sorry, it's a little rough. 16, 17, 18, 19, 20. And I'm going to have to make this a little longer. And do note that sometimes you do have to do that. 25, 30, I'm guessing 35, etc. So that's basically your graph. You're all set up for success. 1, 6, 1, 6, 1, 2, 3, 4, 5. So we're up about there. And then we've got 2, 8. So 2, 8. I'm going a little fast, so I got to be a little more accurate. So let's do this. 1, 6, 2, 8. And then we're looking at 315. So things change a little bit. We got way up here now. 3. Okay. 422. 422. Pretty steep line. And we're starting to see a trend, what's called a trend line, 529. Is that about here? But all it says in this example, it tells you, plot a graph with these data points. We've done that. Draw a trend line by using 2 carefully selected points that best represent the data. So any of these 2 points would work. I'm going to pick these 2. And now, as we go, this is now a little bit different here. It doesn't really cross through there because that point, was a little bit of a different. We had a little bit of a between 1 and 6 and 2 and 8 was a little odd. So, but this is the pattern. This is all you need, and then we go up from there. Now, according to this trend, with the number of baskets is like 7 a game, we're going to be off the hook at 20 games. I mean, obviously Dominic's having a good year. Well, at least relatively good year. I don't know whether you consider 7 baskets a game a good year or not, but anyway, he's pretty steady. And how are we going to find out from here? It says use the equation of your line to predict how many baskets. So we're not going to actually use this graph because it's going to go so far off the charts. When we get to 20, that line is going to be so far up here that it's really not easy to predict. We have to make a giant graph. So we're not going to do a giant graph. What we're going to do is we're going to actually use the equation of the line, in this case, to predict how many baskets at the 20th game. And how are we going to use it? Well, x equals 20. What do you do with that? Instead of x, you put in 20, and then you solve for that. Hold on a second. It sounds simple, but now you're looking at it a little more closely, and you're realizing there's no equation of a line. There's no y equals mx plus b. We don't know the slope. What's the y-intercept? Well, you do know it. It's right there. Slope is rise over run. It's the rate of change, and the rate of change is pretty steady here. If you notice, the change in y over the change in x. So slope, m, okay, equals m, equals change in y over the change in x. Well, what is that? For the most part, it changes 7 over 1, because 22, and if I do it the long way, I might write this. 22, let's say, minus 15 over, in that game, it was 4 minus 3. That's a representation of this. That would be 7 over 1. So m is the slope, is 7, and b is where the line crosses the y-axis. Now, not so simple. We don't see it exactly, but we can solve for that in a minute once we get our slope. So we have y equals 7x plus b, and when the line crosses the y-axis, our x value is going to be 0. How many baskets do you have in the 0 game? You have 0 baskets because it's game 0. So actually this is y-intercept at the origin, and that's 0. And that's why this becomes our equation of the line. There is a b, there is a y-intercept, it's 0. So it doesn't appear to be there, but it's really there as 0. It's an invisible equation of a line. So for 20 baskets, now this is the important thing. So y equals 7x. The question is, what happens after 20 games? Well, we're just simply going to put in 20 in for here, and y equals 140. That's what we fill into the chart. Right back over here. That was what we wanted to know, 140. And there it is, guys. 140 baskets for the year, 20 games. Dominic's a star. Well, at least in somebody's world.